In this video, we are going to learn how to find the maximum and minimum values in the interval by using derivative. Absolute and local maximum, what does it mean? First, we are going to learn this definition. Absolute means the minimum value in the function. Let's say when function is increasing and decreasing, that point, firstly increasing then decreasing, the point on the top, it's going to be local maximum point. And when function first decreasing then increasing, that point also it's going to be local minimum. And these 2 points, they are not absolute maximum, because from the local maximums, which one is the greatest one, that's still absolute maximum it's going to be. So this point is the greatest point with respect to y-axis we are talking. This is the greatest point, so it's the maximum, absolute maximum, or we can say also local maximum for this point. And this point is minimum, but this point is absolute minimum because this is the smallest value on the y-axis. That's why this is going to be the absolute minimum. We can use for the absolute minimum local minimum term also. Here the function firstly, as you see, the first derivative here, first derivative is smaller than 0 means, if you remember, it's going to be decreasing. The function is decreasing, and then it's going to start to increase. So if the function firstly decreasing, then it is increasing, the point that you're going to find, it's going to be local minimum. If the point when firstly increasing then decreasing, firstly increasing then decreasing, it means that it's going to be the maximum point. Maximum of a function is either maximum or minimum value. So generally we are naming the extremum maximum or minimum value for minimum value. And at maximum and minimum value of the function, the derivative must be equal to 0, because as you see, the tangent line is parallel to x-axis, and when the tangent line is parallel to x-axis, derivative is going to be equal to, or slope of tangent line, firstly it's going to be equal to 0. Slope of tangent line, if it is equal to 0, it means that derivative is also 0. So f derivative a, and here this f derivative a and f derivative b is equal to 0. So it means that, this is the last sentence maybe, it means that the derivative is equal to 0 when we have extremum points, local minimum or local maximum points. So finding the extremas here, it says local minimum or local minimum maximum point. When we are finding, first we should say the derivative is equal to 0. If the derivative is equal to 0, let's find first the derivative. F derivative x is equal to 3x squared minus 6x plus 0 it's going to be, but it is nice written. So 3x squared minus, when we say 3x squared minus 6x is equal to 0, we are finding the local extremas. We are finding the local extremas here. And how to find this one? This is first a quadratic equation, and there is no c here. It means that we are going to get the common term parenthesis. 3x is equal to, if we get 3x parenthesis, 3x times, it's going to be x minus 2. 3x times x is equal to 3x squared. 3x times minus 2 is equal to minus 6x. It's going to be, and this is equal to 0. So there are two options now here. 3x is equal to 0 and x is equal to 2, x minus 2, or we can write like this, x minus 2 is equal to 0, x is equal to 0, and x is equal to 2. Now, which one is the local minimum, which one is the local maximum? How we are going to understand this one? For understanding that one, we have to make a plus minus table again. Now, I'm going to write the roots here. I'm going to write the roots of the derivative. This is the f derivative x, and I'm going to write the roots here firstly, and this is going to be equal to 0, and the second one is going to be equal to 2. This is minus infinity side and this is plus infinity side. So function is going to be f derivative x, because it's 3x squared plus, then plus, minus, and plus, it's going to be table. If you remember, when the first derivative is equal to, when the first derivative is positive, function is going to increase. Fx is increasing. when the f derivative is negative, function is decreasing. When the f derivative is positive, function is increasing. Firstly increasing, then this is decreasing. This is going to be local maximum. First, so it means that x is equal to 0 is the local maximum point. Then firstly decreasing, then increasing, this is the minimum point. So this point is going to be local minimum point. On the next question, we are going to define also the critical point. Critical point word maybe we heard many times. When the derivative is equal to 0, it's the critical point it's going to be. And here for this question, find the extreme points it says. And we are going to find that's local maximum or minimum. And we are going to find f derivative x is equal to 0. When we say we are going to find the extreme points. Firstly, this is going to be fx for us, and f derivative, this is 3x squared minus 6x minus 4 plus 6x minus 4, and f derivative x is going to be equal to 6x plus 6. So if f derivative x is equal to 6x plus 6, then it means that 6x plus 6, when it's equal to 0, the point that we are going to find, it's going to be the extreme point. But extreme points here, it's going to be equal to 6x minus 6, 1 point only. 6x is equal to minus 6 over 6, which is equal to minus 1. So we have only one extreme point. With respect to this function, when you think this function is the parabola, when the parabola and the a value is positive, here it's going to be like this. So the point that we are finding, probably it's going to be local minimum, but try to understand that one. We will do the test again, the table test. One is the minus 1 is the critical point. When the values are greater than minus 1, it's going to be positive because the sign is positive here. That's why this sign is important here. It's going to be positive. I'm doing again. If this sign is positive, then this sign is going to be positive, and this sign is going to be negative. Okay, then if it is minus, this is the f derivative x, and the value for the fx, it's going to be fx. First decreasing, then increasing. First decreasing, then increasing means this is local minimum point. Actually, this point is absolute minimum point because we don't have smaller value than minus 1 on the x-axis, of course. Okay, now in this question, it's also given that at x is equal to 1, it has local minimum. So it means that f derivative 1 is equal to 0, like in the previous page. Okay, if f derivative 1 is equal to 0, we should find first f derivative. F derivative x is equal to, it's equal to 6x minus m, it's going to be. So 6x minus f derivative 1 is equal to 0, so 6x minus m is going to be equal to 0. And 6 times 1 minus m is equal to 0. 6 is equal to m, it's going to be, so m is equal to 6 is going to be. Okay, here find the critical points of the function, which means local maximum and local minimum, and it says that define its local minimum or maximum. We are going to define that one. First, I need to get the derivative of the function. Fx is equal to f derivative x is equal to 3x squared minus 6x minus 9, it's going to be. And if I get 3 parentheses, this is 3x squared minus 2x minus 3 is going to be, why I got 3 parentheses? To do easy operation, that's why. And when it is equal to 0, when this expression, when f derivative x is equal to 0, we are finding local minimum or maximum. So x squared minus 2x minus 3 is equal to 0, and x is equal to, x we are going to factorize, x minus 3 and plus 1 it's going to be, so x plus 1 times x minus 3 is going to be equal to 0, x is equal to -1, x is equal to 3, it's going to be. So for the derivative we have two different routes. To understand when it is positive, when it is negative, we are going to make the table again. -1, -3, it's going to be minus infinity, and infinity is going to be, pardon, this side it's going to be plus infinity, and this is minus infinity. Okay, minus infinity side and infinity side it's going to be. And here we have the important part. When these are plus, minus and plus, the function is going to increase, decrease and increase again. So -1 is local maximum point, and 3 is local minimum point, local maximum and local minimum point. I prepared this one before. I draw the function of the x cubed minus 3x squared minus 9. As you see, the function is written here, x cubed minus 3x squared minus 9x plus 6 here, and the same function it's going to be. Then, as you see here, these points are the local maximum and minimum. I already draw the graph and I show the places. As you see, the point is the x value, it's written here, the first value, a -1 and 11. As you see, the -1 is the maximum point, local maximum point, and as you see here, this is the second point, and this is the 3 and -21. 3 is the x value, and we were finding, if you remember, we were finding both value -1 and 3 here. I'm going to show that one again. -1 and 3, this is local maximum and this is local minimum is going to be. In this question we are going to try to find the local extrema, but we have some difficulties here. When we get the derivative, we are going to understand that one. F derivative x is going to be equal to 2 over 3 x to the power of 2 over 3 minus 1 plus 0. The derivative of the 0 is, derivative of the 2, it's going to be equal to 0. So this is 2 over 3 x to the power of minus 1 over 3. This is going to go to the denominator. 2 over 3 root x, it should be third root of x to the power of 1. The power numerator goes to power, denominator goes to index of the root. Okay, this is the expression, and this is the f derivative, but it's, for this expression it's impossible to be equal to 0, because denominator cannot be equal to 0. If the denominator is not equal to 0, we are going to try to find the positiveness and negativeness. So with respect to x, we can find easily when this is equal to 0, when it is greater than 0, it's going to be positive. Then it is greater than 0 because this is going to be positive number, positive over positive, the result is going to be positive. And when it is less than 0, it's going to be negative, because let's say this number is negative, also it's possible because it's cubic root. The function is going to be negative, but it can never be 0. That's why I put open circle there, to understand that cannot be 0. Okay, then this is the analysis of f derivative x. It means that function is increasing here, then it's going to decrease, first decreasing, then increasing. Firstly decreasing, then increasing is going to be. First decreasing, then increasing function is going to be. And I prepared also this one for you. The graph of the x to the power of 2 over 3, x to the power of 2 over 3, and here x to the power of 2 over 3. Then this graph, the graph of the function, it's going to be like this here. As you see, at 0, the function, when x is equal to 0, firstly decreasing, then increasing. Well, it's going to be, and this is corner point, that's why we don't have this at this point derivative. And by the way, I said f derivative cannot be 0 there. If derivative is 0, it means that we can differentiate there, but as you see, corner point cannot be differentiated. Okay. This is the last question. It's going to be the function x cubed plus ax squared plus 15x plus b has local maximum at 1 and 10. If it has local maximum, it means that the derivative, f derivative x, let's say first it's equal to 0, 3x squared plus a times 2ax plus 15, it must be equal to 0 at x is equal to 1. And f derivative x is going to be equal to f derivative x is equal to 0, means this is the local maximum or minimum, but it's given in the question, it's local maximum. So f derivative 1 is equal to 0, sorry. And f derivative 1, if it's equal to 0, it means that 3 times 1 square plus 2 times 8 times 1 plus 15 is equal to 0. It's going to be 2a plus 18 is equal to 0. 2a is equal to minus 18. A is going to be equal to minus 9 after the operation. So I found the a value. It's easy to find b value because I know this one. fx is equal to, now it's equal to x cubed minus 9x squared plus 15x plus b. I found the a value, and it's easy for me to find the b value because I know that f1 is equal to 10. Why it's like that? These are x and y values, and when we have fx, it's giving us the y value. So f1 is equal to 10 means f1 is equal to 1 cubed minus 9 times 1 squared plus 15 times 1 plus b is equal to 10, and from this value we can find the b value. Here 1 minus 9 is going to be equal to minus 8 plus 15 plus b is equal to 10, and minus 8 plus 15 is going to be equal to plus 7. Plus 7 is not written as plus 7. 7 plus b is equal to 10. So b is equal to minus 3 plus 3 is the answer of our question. And b is equal to, a is equal to minus 9, b is equal to 3 is the solution of this question.